Deep learning is changing the world. It's a powerful type of artificial intelligence that learns from data. Deep learning powers many technologies we use daily, like voice assistants and self-driving cars. Deep learning uses artificial neural networks to learn. Think of these networks like the human brain, but much simpler. These networks process information and make decisions just like our brains. Deep learning's impact is huge. It's improving healthcare, finance, and many other industries. Deep learning is a rapidly evolving field. It's an exciting time to learn about this transformative technology. Deep learning draws inspiration from the human brain. Our brains have billions of interconnected neurons that process information. These neurons communicate through electrical and chemical signals. This complex network allows us to learn, think, and make decisions. Deep learning mimics this structure with artificial neural networks. These networks have layers of interconnected nodes that act like neurons. While simpler than the human brain, artificial neural networks can still process vast amounts of data and learn complex patterns. This connection to the brain makes deep learning a powerful tool for solving complex problems. Neural networks are the building blocks of deep learning. They are computational models inspired by the human brain. These networks are made up of interconnected nodes called neurons. Each connection between neurons has a weight, which determines the strength of the connection. Neural networks process information by taking in input data and passing it through layers of neurons. Each neuron performs a simple calculation on its inputs. This process transforms the data at each layer, allowing the network to learn complex patterns. The output of the network is a prediction or classification based on the input data. Neural networks have a layered structure. Each layer plays a specific role in processing information. The input layer receives the raw data, such as images or text. The hidden layers process this data, extracting features and patterns. The output layer produces the final result, like a prediction or classification. The number of hidden layers and neurons in each layer can vary depending on the task. Deeper networks with more layers can learn more complex patterns. This layered structure allows neural networks to handle high-dimensional data and make accurate predictions. Data flows through a neural network in a specific way. This process is fundamental to how neural networks operate and learn from data. Understanding this flow is crucial for anyone looking to delve deeper into the world of artificial intelligence and machine learning. It starts at the input layer and travels through each layer until it reaches the output layer. The input layer is where the raw data is fed into the network. This data can be anything from images to text to numerical values depending on the application. At each neuron, the inputs are multiplied by their corresponding weights and summed together. These weights are parameters that the network learns during the training process. The sum of these weighted inputs is known as the weighted sum. This sum is then passed through an activation function. The activation function is a mathematical equation that determines the output of a neuron. It introduces non-linearity into the network, which is essential for the network to learn complex patterns. The activation function introduces non-linearity into the network, allowing it to learn complex relationships in the data. Without this non-linearity, the network would be limited to learning only linear relationships, which are often insufficient for real-world tasks. The output of the activation function becomes the input for the next layer. This process of passing data through layers, applying weights, summing, and activating continues throughout the network. This process continues layer by layer until the data reaches the output layer. Each layer in the network can be thought of as extracting different levels of features from the input data, with deeper layers extracting more abstract features. The output layer produces the final prediction or classification based on the processed information. This final output is what the network has learned to predict or classify based on the input data it was trained on. The entire process from input to output is what enables neural networks to perform tasks such as image recognition, natural language processing, and more. Activation functions are crucial components of neural networks. They introduce non-linearity into the network, enabling it to learn complex patterns. Without activation functions, neural networks would only be able to model linear relationships. This would limit their ability to solve real-world problems. There are various types of activation functions, each with its own properties. Some common ones include the sigmoid, ReLU, and TAN functions. The choice of activation function depends on the specific task and the characteristics of the data. Activation functions are essential for neural networks to learn and make accurate predictions. Backpropagation is the key to how neural networks learn. It's an algorithm that adjusts the weights of the connections between neurons. During training, the network makes predictions based on the input data. The error between the prediction and the actual target value is calculated. Backpropagation propagates this error back through the network, adjusting the weights to minimize the error. This process is repeated iteratively with many training examples. Through backpropagation, the network learns to make more accurate predictions over time. By adjusting the weights, the network fine-tunes its understanding of the data. Deep learning is transforming numerous industries, bringing about a revolution in how we approach complex problems and tasks. Its ability to analyze vast amounts of data and make accurate predictions is invaluable. Data scientists leverage deep learning to uncover patterns and insights that were previously hidden in massive datasets. In healthcare, deep learning is used for medical image analysis, disease diagnosis, and drug discovery. Doctors can now detect diseases at an earlier stage with greater accuracy, thanks to AI-powered diagnostic tools. Additionally, deep learning accelerates the drug discovery process by predicting how different compounds will interact with the human body. In finance, it's used for fraud detection, risk assessment, and algorithmic trading. Financial institutions rely on deep learning algorithms to identify suspicious activities and mitigate risks. Moreover, these algorithms enable high-frequency trading, making split-second decisions that can lead to significant financial gains. Self-driving cars rely heavily on deep learning for perception, navigation, and decision-making. These vehicles use a combination of sensors and AI to understand their surroundings, plan routes, and make real-time decisions to ensure safe and efficient travel. Natural language processing, powered by deep learning, enables chatbots, machine translation, and sentiment analysis. Chatbots provide customer support and automate routine tasks, while machine translation breaks down language barriers, making global communication more accessible. Sentiment analysis helps businesses understand public opinion and tailor their strategies accordingly. These are just a few examples of how deep learning is revolutionizing our world. From enhancing healthcare outcomes to transforming financial markets and enabling autonomous vehicles, the impact of deep learning is profound and far-reaching. Its applications continue to expand as the technology advances and more data becomes available. As we move forward, deep learning will undoubtedly play an even more significant role in shaping the future, driving innovation, and solving some of the most pressing challenges of our time. The future of deep learning is incredibly promising. As we look ahead, the potential applications of this technology seem almost limitless. From healthcare to finance, education to entertainment, deep learning is poised to revolutionize every sector it touches. Imagine a world where medical diagnoses are more accurate, financial predictions are more reliable, and personalized education is available to everyone. This is the future that deep learning promises. As research and development continue, we can expect even more groundbreaking applications. Scientists and engineers are constantly pushing the boundaries of what is possible, developing new algorithms and models that can tackle increasingly complex tasks. These advancements are not just theoretical, they are being applied in real-world scenarios, solving problems that were once thought to be insurmountable. Advancements in hardware, such as more powerful GPUs, will enable the training of even larger and more complex neural networks. These hardware improvements are crucial, as they provide the computational power needed to process vast amounts of data quickly and efficiently. With more powerful GPUs, we can train models that are not only more accurate but also more capable of understanding and interpreting the world around us. This will open up new possibilities for solving challenging problems. For instance, deep learning can be used to predict natural disasters, optimize supply chains, and even create art. The potential applications are endless, and as the technology continues to evolve, we will see even more innovative solutions to the world's most pressing issues. Deep learning is also merging with other technologies such as cloud computing and edge computing. This convergence allows for more efficient data processing and storage, making it easier to deploy deep learning models on a large scale. Cloud computing provides the infrastructure needed to handle the massive data sets required for training deep learning models, while edge computing brings the power of AI closer to the end user, enabling real-time decision-making. This will make deep learning models more accessible and scalable. By leveraging the power of the cloud, organizations of all sizes can take advantage of deep learning without the need for expensive hardware. This democratization of technology will lead to a surge in innovation, as more people have the tools they need to develop and deploy AI solutions. As deep learning continues to evolve, it will undoubtedly shape the future of technology and society. From smart cities to autonomous vehicles, the impact of deep learning will be felt in every aspect of our lives. It will change the way we live, work, and interact with the world around us, creating new opportunities and challenges that we must navigate. Its impact will be felt across various industries and aspects of our lives. In healthcare, deep learning can lead to earlier disease detection and personalized treatment plans. In finance, it can improve risk management and fraud detection. In education, it can provide personalized learning experiences tailored to each student's needs. The possibilities are endless, and the future of deep learning is bright.